So today's pedigree chart is a little bit different from the ones we've been doing. And my claim is I want to find out what widow's peak is. Is it a dominant trait or is it a recessive trait? Now, the first thing I have to tell you is it is not sex-linked. And this says this in the handout that I gave you. And I just have to tell you that usually. In fact, if you try to work this problem out as an X-linked problem, it won't work. It's impossible. Not every trait is sex-linked, so you just have to make sure you read the questions and look for things that say whether it is or is not sex-linked. So this is not a sex-linked problem. So this is a little different. Now, the first thing you might assume is, well, it might be recessive, because those are the types of problems that we've been doing. But if we assume it's recessive, let's just pretend it is for a second. That means this person is little a, we'll use A's. This person is little a. And we see right away that now this is impossible. There's no possible way to get these two children down here. How are we going to get this child and how are we going to get this child? And you can't. So this proves this family right here, in fact, just these three people is really all you need. This one is a bonus. This proves that it is not a recessive trait. Instead, it's a dominant trait. Now, let's go back and fill in the Punnett square with the correct genotypes so we can see how it is a dominant trait. So now we know that it's a dominant trait. So I'm going to go ahead and write dominant here. But let's prove it now. So it's dominant. So this is exactly opposite of a recessive trait. So now all the people that are not shaded in are recessive. So little a, I'll do everything just like before. I'm going to fill in everybody that I know. So all the non-shaded in individuals are homozygous recessive. And all the people that are shaded in, we know, are at least a big A, because the trait is dominant. So I'm going to fill in big A on these. And big A. Now we have to ask ourselves what the other allele is. Well, let's look down here, and we still ask ourselves the same questions. What did he get from his mom? What did he get from his dad? So we see this individual down here in the bottom corner is homozygous recessive, so he must have gotten a little a from his dad and a little a from his mom. So we know those two are heterozygous. Now their daughter here, what do you think she is? We really can't tell. She got the big A from one of the parents, but we don't know what the other allele is, so we have to put a question mark on her. Let's see, do we know this boy here? Oh, what did he get from his dad? He must have gotten a little a from his dad and the big A from his mom. What about his mom? Do we know his mom? We do, because she had a son down here that is little a, so that means what did he get from his mom? He must have gotten a little a. And we know everybody on the pedigree. Now for our next claim, we want to find out what the chance, so chance means Punnett square, what's the chances that these two individuals will have a child with widow's peak. So it's these two people right here. I figured that out before. So now I'm going to create a Punnett square for these two people. So I say big A, little a, and I construct my Punnett square. And both parents are heterozygous. So I fill in my Punnett square. And I find out that 3/4 of my children can have widow's peak. So 3/4, that would be 75% of my children would have widow's peak, and 25% would not. 25 would not have widow's peak. So if I go back to my claim, individual 2-1 and 2-2 have a 75% chance of having a child with widow's peak. Now for my next claim, I want to find out if these two individuals, 1, 1 and 1, 2, what their chances of having a child with widow's peak are. So again, I do the same thing as before and construct a Punnett square. So my cross is little a times big A little a, homozygous recessive times heterozygous. So I create the Punnett square, little a, and big A, little a. This child has widow's peak, this child has widow's peak, no widow's peak, no widow's peak. So now we know what the chances are of having widow's peak or not having widow's peak.